Okay. Boom. 5.1 HO2 notes. Today is day 1. We're doing it. What is f of 2 asking for? Easy question, but it's almost too easy, too simple. We really gotta actually think about this because we're gonna see questions like f of 2 and we're gonna see questions that are really similar to f of 2 but different. What is f of 2 asking for? Response from the crowd. What do you got, Devin?
What is y equal when x equals 2?
Yes. All right, so what we're looking for here is what is y when x is 2? Or what is output when the input is 2? You know, we use x and y with input output pretty generously. And so based on the table here, what is f of 2? 4, right? It's like, okay, this is so easy. Wow, you know, senior year is gonna be a piece of cake. Nice. Okay, now let's scroll down here and let's look at this. Based on this table, what is g of 2? Oh, we got our first typo, right? We're gonna fix that, right? We gotta add there. That's okay. Based on this table, what is g of 2? Answer from the crowd.
Also 4.
Is it though?
Not based on the table.
Is it though? So look at these, you know, 2 questions. When it comes to the first question, is this a guaranteed truth?
Yes.
Yes, of course. When it comes to the second question, is it a guaranteed truth? No. But your brain is like, I mean, kinda. Like, what more do you want? 3.99, 4.01? Like, surely. So, something about this is telling us the answer should be 4. It's getting really close. Our brain is making the connections. So, I'm gonna go back up to this top here, okay? And this, what is f of 2 asking for? This is based on real. This has to be the real true thing, okay? Maybe we even could use a word like truth, okay? This has to be the accurate answer, the truth of where it is. And so for this one, I like this. But for this second question here, talking about G, as far as we're concerned, I'm not sure. We can't say that G of 2 is 4 because G of 2 is reality, it's the truth, it's the real world, and we just don't quite know. Well, what kind of math are we doing when it's this easy and it doesn't really quite make sense? So let's look at it here. Now let's look at the graph version of the same question. Based on the graph of f, what is f of 2? You got your little grids there, count them up. What do we think? Yeah, right? Here's x of 2, and so we're looking right here, and that's 4. Is that the truth? Is it really 4? Yeah, it's really 4. The answer is 4, okay? The line is there. The line is 4 at 4, and of course, you guys are smart kids. You recognize patterns. You're already, you know, anticipating what's going on in the second graph there. Well, it's the same graph, except for there's a little bit of a difference. What's going on here? We have a hole. A hole, denoted with a little empty circle along our line, is missing information. It is a gap in the line, and this is just like the table, okay? Just like the table, even though we can say 1, 2, and look right here, it's at 4, That empty hole, that empty little piece there is telling us f of 2 is not 4. In fact, as far as the information that we are given, f of 2 does not exist. And so does not exist is like some vocab that we'll use a little bit. We'll be shortening it to D and E, but these values can not exist. Okay, again, the thing about what we're gonna learn today is don't let your brain overcomplicate this. It is a simple idea. Is the line there? Cool. Is it not there? Also cool, right? It's not, there's not really any difficulty to it. We're not having to do some algebra. We're not having to do all this crazy stuff. We just gotta keep that straight in our head. Okay, flipping it over. Notes so far. What do we think? Yeah, nice having the paper. All right, the notes for today are on limits. Let me talk to you just a little bit about how IB works, okay? Normally, if I teach calculus or if I teach AP calculus, calculus has like 3 topics and they're all mostly equal, right? It's like 30% of the class, 40% of the class, 30% of the class. And the first one is limits. And so you do limits for like 30% of the class. IB basically completely gets rid of limits. And so instead, our class, topic 5, will be like 5% limits. So literally like just today and a little bit tomorrow, we'll be doing limits. And that's it for limits. So not only is limits a pretty easy thing, but we're only gonna be doing it for like 2 days. So we're not really getting into the hard limits. We're not getting into the deep limits. So let's just keep it nice and easy and talk about it, okay? Limits is the reason we're talking about these weird questions where it's almost, okay? Limits is what your brain expects. And that's not probably how a math textbook would define it. But again, the thing about limits is just keep it as easy as you can in your head, okay? If we go, and you don't have to flip back, but if we look at this, is f of 2 4? Yes, of course. Is f of 2 4? It is not. But the limit is 4. The limit is almost like what it should be. The limit is like what you predict it would be. Instead of me showing you the graph that looks like this, if we think about the question, if I said, hey, what do you think's behind my hand? You'd say, oh, probably 4. That's all the limit is. It's that simple. It's just what your brain is predicting. It's when the 2 lines look like they're about to touch, but there's a hole. Well, that's the limit. So limits shouldn't be super crazy. They have a bit of a notation. One of the things about calculus is that we have a whole bunch of notation and it starts to look complicated, but it's never really that complicated. Limits are gonna have the word lim, short for limit, all right? No surprise there. Then we're gonna have an arrow underneath limit. Now this gets pretty annoying if you're working on lined paper because it's like, should I cram it all into one or should I spread it out into 2 lines? It gets kind of annoying because it's a stacked up function, okay? Then here, we'll have an X. Let me use a different color. This is obviously a variable. It's pretty much an X every time, right? I mean, you do questions sometimes that have different letters like H or V or something, but it's pretty much an X every time. So the limit as X, and what this is saying is the limit as x approaches, and let's use the same question from yesterday, or from the page before, not from yesterday. You'll get a question or a number here, like 2. And this is going to be a number. So the idea here is that it's saying the limit as x approaches 2, or the limit as x goes to 2. But we also need to make sure we're talking about what? The limit as x approaches 2 of what? And so most of the time you'll see just an f of x after the limit. And that would just be obviously a function. Now, important to write is the kind of verbal thing that I've been saying here. So this is, we'll do quotes, this is the limit as x approaches whatever number that is, we'll just say 2 of f of x. Or you could even put the f of x part in the middle. You could say the limit of f of x as x approaches 2. But the whole idea is that it's about what your brain expects as you get close. So let's go back for a second and let's just keep all of this going in our head. It has nothing to do with what's going on right here. Okay, again. Doesn't matter what's going on there. It's all about this. As your brain is getting closer and closer and closer to 2, what does it think is gonna happen? That's the only thing that matters, is what do you expect to happen? It's like a prediction. And again, it's not hard. Just look at it and tell me the number. Okay, key concept. This is the most important thing. This is something that if you miss, I don't have a whole lot of sympathy for you. Come on, you gotta get this right, okay? F of x is not the same thing as the limit as x approaches x of f of x. These are not the same thing, okay? This is reality. And this is expected or predicted. And they do not have to match, okay? It's a classic question where I say, you know, what's the limit? And somebody says, well, the answer is 5. It's like, well, we don't care about what it really is. We only care about what is expected. Again, it's almost such an easy concept that we can get kind of confused by. Okay, let's do some questions here. What, for this question, is the limit as x approaches to f of x? Then after all this, we can put an equal sign, and then we can put the number. I know I'm writing it quite big here, but what do we think? Easy, right? 4. Not meant to be hard at all. It's the same answer we've had for every question that we've done so far. It is 4. That's the limit. Because that's what it probably should be. But what is f of 2? Does not exist. So again, key concept, we gotta keep these two things separate in our brain. They're not the same. But they're both easy, both separate. Okay. What about this one over here? What is, what is the limit as x approaches 2 of this different f of x, where we have an upside down absolute value graph. Anybody got the limit? Layla. Come on, you got the guts for this.
I was sorry.
You got it. It's 4. It's 4. Nice job. It looks like it should be 4. Boom. What is actually f of 2, Grady? 4. Are they allowed to be the same?
Yes.
Of course. In fact, they're almost always the same. Every graph you've ever looked at your entire life, probably 99.999, maybe like 3 graphs you've ever seen, have them disagree. But now we're in calculus where I will purposefully make a question where they disagree. But most of the time they do agree. But when we do these calculus questions, they will probably be different. Okay. Okay, let's check this out. What the heck's going on here, right? We got some funky, boom, chopped up graphs, okay? This is a piecewise graph, right? We're not gonna be able to come up with some simple one-dimensional function that's just gonna work nicely here. This is probably a piecewise function where we're saying that this graph happens before 2 and this graph happens after 2. Let's start with the easy question. What is f of 2? In reality, truly, what is f of 2? Devin? 3. It is 3. And it has to be 3. And we better make sure that we're comfortable with why it is 3. Let's look here at 2. We've got kind of 2 pieces that aren't matching. One of them has a filled in circle and one of them has an empty circle. Which one do we care about when we're looking for the true reality place of the graph? Of course, the filled in circle. We feel good about that? Lizzie, you got that? Nice. Now let's talk about the limit. The limit as x approaches 2 of this funky function, f of x. Now, let's think about this. As we are approaching 2, what do we think it's gonna be? All right, I'm gonna talk with Luke on this one. Luke, we're starting over here. You ready? Let me do this first. Okay, here we go, Luke. Luke, what is it gonna be? 3. Luke thinks 3. Sounds good. Who wants to go? Jack, we're on this side. You ready? What do you think? 2. So we have an issue. We have 2 sides of our brain, and in fact, for this question, making a prediction isn't making much sense. Remember, when it comes to limits, we do not care that the true value is 3. We don't care. It doesn't even exist. Truly, when we're doing limits, there is a giant red chasm of fire that is blocking our knowledge of this. It does not matter. A mistake would be to say, well, Luke should be right because the true answer is 3. That's not how it works. The only thing that matters for limits is to make a prediction. Can we make a prediction that we all agree on for this function? At 2. No, we can't. Because some of us might have shaggy blonde hair and we think it's 3, and some of us might have curly brown hair and we think it's 2, and we just will never, we'll just never agree. So, the limit does not exist. So we've now seen easy questions where the function does exist and easy questions where the limit does exist. exist. We've also seen easy questions where the function does not exist, and we've now seen limits where they do not exist. So, let's look about this over here. Now here's the thing. Even though I made these notes and most of these boxes are mostly blank, it still took me a very long time to come up with these, and sometimes I'm gonna get to a box like this, and I'm not really sure what's gonna go in here. So, let's come up with something, because I think I got it, okay? When looking at the graph, okay, f of x is where dot is. And that's it. That is as complicated as it will ever be. If I ask you for f of x, where is the dot? When looking at the graph, the limit of f of x as x approaches whatever number that is, x I guess, has to be where both sides look like they are going. Importantly, it's got to be both sides, right? We just saw an example where they disagreed and can't really make a prediction. Okay, we're moving on. That will introduce one-sided limits. This is the last page, right? Or no? Okay. Oh, yeah, I got you. This stuff's really easy though. One-sided limits will show up, okay? One-sided limits asks only about one side, no way. And so, if we do a question like this, the notation would say the limit of f of x as x goes, and I'll just put the number 2, it doesn't really matter. I'll put it in red, because it could be any number. And then, in this area here, like an exponent, it will be either a plus or a minus. So I guess I'll maybe just write it again. The limit of f of x as x goes to 2 minus. Now that ends up being a pretty small little thing, because you have, again, the limit of f of x probably scrunched a little bit small. And then within that, the little 2 has even a smaller exponent, and in that exponent, it's only a tiny little plus, or an even smaller little minus. So these can be pretty small, okay? Okay, let's go back to this question here. I used this a little bit yesterday, and it was doing a good job, but now it's struggling again. Okay, let's look at this. We talked about how the true value is 3. Sure. We talked about how the limit does not exist. But the one-sided limits almost certainly will exist. We'll see a small example where they don't exist. But so what I can have here is the limit of f of x as x goes to 2. Now if I'm talking about this purple side, this side that Luke helped me with earlier, do you think that would be the negative or the positive?
Positive.
Well, we've got a disagreement here. What do we think? Positive or negative? Girls up front, what do you think?
Negative.
Disagreeing again? All right, Leona, help us out, break the tie. You think this is the positive or the negative side?
Negative.
You're so right. This is the negative side. Think about it like this. like which side is coming from negative infinity, right? Which side is coming from the negative region of the graph? Here's all the negative numbers over here, and this is as we approach 2 from that negative side. So, importantly, make sure that we put a little negative here. And these are the answers that Luke and Jack were answering already without even knowing anything about one-sided limits. It's just whatever you would think on one side. This is equal to 3 because it looks like it's going to be 3. And then over here, the limit as x goes to 2 with a little plus of f of x is, again, when you're answering this question, it's a simple thing. There is positive infinity as we approach, and all of this information doesn't exist. You're not allowed to use that information. You're only allowed to walk along the line 2. Okay. I'm looking for, this is limits to infinity. I wish I had one more box here. Do we still have room in this notation box? Probably. For the most part, you guys probably do. I know we're going back and forth a bit. Okay, here's what I want to write. If, let's make a little theory here. Let's make a little hypothesis. If the limit as x approaches a of f of x exists, then what? So we've seen some where the limit exists, like the first several that we had, and we've seen most recently one where the limit does not exist. It was one of these. It looked like this. It looked like this. There we go. So, if the limit exists, then what is true? Yes, both one-sided limits are the same. So if we're going to write it mathematically, we could say that the limit of f of x as x approaches a from the negative side should be equal to the limit as f approaches x from the positive side. Okay, here's why I wanted to write this down, right? If you go and you maybe Google this, or you look in a textbook, you'll see something like this. And honestly, this reads like it's maybe difficult. But this is not a tough concept. If you can make a prediction for what it should be, then the two sides should match up. And it is that easy, right? Can you make a prediction here? No. What about now? Yeah, there you go. That's everything that we've learned here, okay? You just gotta keep it simple in your head, and you'll be all right. Okay, we've got limits to infinity. These are super, these make a lot of sense here. It could be something like the limit as of f of x as x goes to infinity. And of course, going to infinity means it's going this way forever. You could also have, or the limit as x goes to negative infinity. You will not have one-sided limits with infinity limits, of course, because you can't approach positive infinity from the positive side of it. It just doesn't make any sense. So you'll never have one-sided limits that are also at the same time as infinity limits. So let's look at these two here. The following function is exponential. So the limit as x goes to negative infinity of this function, I suppose it's not labeled, now it's labeled f of x, is, what'd you say? 0. It's 0. That's how exponential equations work. They have asymptotes here that do not let them pass 0. And just look at the picture. Where do you think it's going? It's going to 0. That's how it works. Okay? Remember, limits are just make a prediction, right? Is it obvious where it should be going? Yes. 0. What about the limit of f of x as x approaches positive infinity? What do we think about that one? Where's this line going? It's going up. It's going up forever. It's just going up and up and up and up. If x gets bigger, it goes up even more. If x gets bigger, it goes up even more. The answer here is infinity. For these questions about infinity, most of the time your answers are either it's going up, infinity, it's going down, negative infinity, or it's getting trapped on like a horizontal asymptote. So this is something that's called end behavior that you learned in Algebra 2, and it's the same exact thing. It's just end behavior, what's happening on the ends of the graph. Is it going up, down, or horizontal asymptote? Now this graph here, the following function is reciprocal. I'm going to write 4 questions here. My handwriting so far has been giant and not very good, so I'll try to do better. So we're gonna do 4 questions here. Let's start with the limit as x goes to infinity of this function. I'll call it g of x. And we're gonna do random student selection. Random integer. We've got 1 through 9, and I'll be number 10. Person number 2, Layla, you win. The limit as our graph goes to infinity is? What do you got? So, where are you looking? Are you looking on the left, the top, the bottom, or the right side of the graph? Right. Excellent. This graph, does it look like it's going up forever, down forever, or is it stuck on an asymptote? Right. The answer is going to be 0. The answer is going to be 0. Excellent. Of course, the next question I'm going to ask you is the limit of g of x as x is going towards negative infinity. Person number 5. 1, 2, 3, 4, 5. Grady, what do we think as it's going towards negative infinity?
Also 0.
Also 0. All right. Okay. Here's what's going on. I'm looking for a question where the answer is infinity. Can you create a limit where the answer is infinity? The first thing you need to do is find where on the graph is it going to infinity. And then, can you make a limit to create that? And it's not meant to be that hard, right? You know that it's limit of g of x as x goes, and that's what you need. That little piece is the only last piece. Now this might be a little bit of a harder question, so instead of going random, anybody want to volunteer for this one? Devin, you got it?
0 to the right side.
So if we say 0, we would have a problem because these do not agree from both sides. So we need to have a one-sided limit, just like Devin said, and we need to come from the right side. Devin, is that a positive or a negative? It's a positive. There you go. And sometimes we have an idea of like, well, 0 can't be positive or negative, so why are we putting that? That has nothing to do with the positive or negative of the number. That's just from the right side or from the left side. So this would be a right-sided limit, because we're coming from the right side, we're coming from the positive side, and the answer here would be infinity. And of course, let's just put this last one. The limit of g of x as x approaches 0 from the negative side would be negative infinity. All right. We're doing great on time. Excellent. Solving for limits algebraically. Okay? Here's my opinion. We're gonna do a quiz. It's gonna have some limits on it. When it comes to those graphs, you need to get every single one correct. Honestly, you have, in my opinion, no excuse to be looking at a graph and miss a question. And maybe you miss one small piece just because you got a little careless and you just lost your focus a little bit. And I know that that happens. But those graphs, we gotta get every single one. When it comes to these equations, I understand they can be a little bit more difficult, but again, you can't overcomplicate these in your head, right? You've got to keep them as simple as you can keep them. So, here's what we're looking for. Solving for limits, instead of a graph, I've given you the function, no calculators allowed. You're not allowed to look at the graph, okay? So, what is the limit as x goes to 3 of this function? I walk outside, I lock the door, I lock you guys in here. You can't leave until you solve the question. My only advice to you is, don't overcomplicate it. It's just limits and they're easy. So what are we gonna do? We're thinking too hard. We're trying too hard. If we're trying to look at where this function is going to be at 3, why don't we just plug in the 3, right? Is there any reason that tells us that this graph is a crazy, funky, weirdo graph with crazy limits? It's just a regular old graph, which means it's just going to be a regular old graph, which means it's just going to have regular old limits. So we're just going to plug it in. Just stick it in there and see what you get, okay? It's going to be 3 times 3 squared plus 2 times 3 minus 5. Again, we can't be missing these. We're just plugging them in, easy peasy. That's 3 times 9, which is 27 plus 6 minus 5, 28. Maybe you can miss them today because it's been a long time since we did math. I haven't done math like this in a long time myself, so maybe I'll make a mistake at some point, but the key concept is you need to think, is there anything scary where I'm going? Can you just plug the number in? Cool. Do it. You're done. That's it. This graph is a quadratic graph, which means it looks like this, and it has no breaks, no holes, no skips, nothing funky. It's just a U shape. So you know what? Just go look. Okay? Now, on your quiz, I'll give you like 2 of these. All you gotta do is plug them in and you get your answer and you're done. Easy. But surely there's a more hard question where you have to do more than just plug in the number. So we've got a question like this next one. The limit as x goes to -1 of this function, x squared minus 3x plus 4 over x plus 1. And so we're gonna ask the question, is there anything scary where we're going to -1? Got some scaredy cats in the back, but yes, we have a problem, okay? When we try to plug in this -1, it's not gonna work. We're gonna have a problem, okay? And I'll do it just because it's the first one that we're doing, but I'll never do this again. On top, you get 1 plus 3 plus 4, which is 8. But the bottom is where we have a problem. -1 plus 1 is 0, and so we have 8 over 0, and yeah, that's not good. You're not allowed to divide by 0. So, plugging it in just does not work. So what can we do instead?
Plug something very, very close to
I'm following you, and you know what? That is a reasonable idea, although depending on, you would have, the long answer is that will not be counted on like an IB exam or a regular AP calculus exam. That's not a good enough way to do it. However, logistically, if you were stranded on an island, it probably would be good enough to do it that way. But that is also probably harder than the real way to do it, okay? So, what's going on here? We've got a relatively nice equation, and it has only one problem. And where is the only one problem? Exactly where we need to look, right? Because I'm a math teacher and I made the question, and of course, this is a totally fine equation that has no problems at all, except for at one place, which is -1, exactly where we need to go. So, that means that this question should be a totally normal graph, except for it has one problem at this -1 place, which is exactly where we need to go. But the good news is that we can still find a limit if it has a problem at one small place. We can still find the limit of this question if there is a gap, just like we did on a question like, I'm not quite sure what causes it to do this. I think I just need to wait longer for it to load. Just like we did on a question like this, where there's one small issue, we could still find the limit, which is 4. Even though there's a gap, even though there's a problem, we're still able to make a prediction. This is called a hole. Algebraically, what is a hole? Where does a hole show up in Algebra 2 when you learn about holes? Right. When a function has two factors, top and bottom, that both cancel out. So what's going on here is that before we plug everything in, we want to look for holes. Basically, this is just a factoring question. This question right here is just an Algebra 2 check. Can you do Algebra 2? That's it. Okay, there's really no calculus involved here at all. It's just pure Algebra 2. So let's look at this question and let's do some Algebra 2. What we need is for this x plus 1 to cross out with also an x plus 1 on the top. And that means not only is it an Algebra 2 question, but it's an easy Algebra 2 question because we already probably know one of the factors because it's probably going to cancel out because the math teacher made the question. So what we're going to do is we're going to write on the next line, limit as x goes to -1, x plus 1 on the bottom. We're probably going to have an x plus 1 on the top, just being honest, just predicting, because that's how these questions work. and these are gonna cancel out. But I'm kind of getting ahead of myself because we need to figure out what is the factor of the top equation. Now I've given you a pretty easy one, a pretty, standard, easy to do one. You might see a harder to factor equation up there, or I should say expression up there. What's the other function? Anybody got the other factor? Come on. Two numbers that multiply to make 4, that subtract to make -3. Is it just a busted equation? Because it should be, the whole thing is not even right. It should be -4, then it'll work, right? I'm asking you guys to do it. Okay, we found a second mistake has hit the nose, unfortunately. We need to fix that. You're right, this top one can't even be factored. Well, the truth is that this question, I guess, has no limit. But let's change the question to make it work. That's okay. We'll need to change this. It can't be a +4 in order for it to work. It would have to be a -4. What a bummer. X squared minus 3x minus 4. Now if it's a -4, we can factor it better. Multiplies to make -4, adds to make -3. X minus 4, x plus 1. Well, disappointing. I let you guys down with a little bit of a typo at the big question, but that's all right. That means this should be x minus 4. That means now we can cancel out these. Why are we allowed to do this? You shouldn't really be allowed to just get rid of parts of your equation if you're trying to solve a question. You shouldn't be allowed to just throw this stuff in the trash can. The reason we're allowed to do this is because limits don't care about holes. And so when it comes to this, and x plus 1 being a hole at x equals -1, limits just don't care about those holes. And so you're just allowed to trash as many holes as you want. So as far as this question is concerned, we can go and write on the next line the limit as x goes to -1 of x minus 4. We can just straight up get rid of that other stuff. It's gone forever, it crosses out, and that is allowed. At this point, we're always gonna ask the question, Mr. Collier, do I have to write limit over and over and over again? Yes, definitely. You have to write the limit as x goes to -1 every single time, because if you don't write that, you're not allowed to cross off the holes. The only thing that is allowing us to cross off the holes is because we are a limit, and if you don't write the limit, then it's just a way for them to be picky, but you have to write limit every single time, and you'll get over it. You know what? It makes you feel like you're doing a very fancy, hard problem, when this is actually a pretty easy problem. Now, at this point, we've gotten rid of our only issue. We have basically a new question, and just like I said before, ask yourself, is there anything to be scared of where we're going? At this point, no. There was a little bit of a pothole, we just threw it away, and now we're not scared anymore. So now, what do you do when there's nothing to be scared of? Just plug it in, just be done. So the final answer for this question, the limit as we go to this, is equal to what?
-5.
-5. Okay, so let's talk about holes here and how we're gonna do this, okay? Most likely, when you go to do these algebra questions, okay, we will have something in the denominator that causes issues. Okay? And so, factor and hope it's a whole. Cross it out. Throw it away. Keep going. You run into a problem, you factor it, you cross it out, throw it away, and then you just say, do I have any problems now? Probably not. You can just, I'm so disappointed that I put that plus there, but that's okay. All right, we've got one last thing. So far we've looked at tables, and we haven't done more about tables, but tables are very easy. We looked at a lot of graphs. When it comes to graphs, the dot is the true value, that's the f of 2 or whatever. The limit is what you predict, and if they don't match up, then there's no limit. Then we looked at one-sided limits where they could have different limits, and if you're gonna have a real limit, the two different sides need to be equal to each other. We looked at algebra, factor it, get rid of it. In my opinion, everything's pretty straightforward. And then we get this far into the question, and into the notes. This is not a complicated thing, but everybody likes to just brain fart when it comes to this type of question, okay? So, in my opinion, this is probably the most likely to be missed question, even though it's not hard. So, here's me trying to help you lock in and get ready so that we can do this question, because it shouldn't be too bad, okay? Let's look at what this is, okay? This is called a piecewise function, okay? A piecewise function is basically just a chopped up function, okay? It's like a transformer robot where it's just all this random stuff being combined together, right? So, what we need to make sure we notice are these commas in here. Those commas are separating the first part, which are functions. Normally they are very simple, which is why these questions should not be very hard. You see we have 2x plus 3, x squared minus 5, and 10. Those are pretty easy functions. And then the right side are basically when is each thing supposed to be happening. So it's all like basically like kind of rules, okay? You are gonna follow this if your x is bigger than 4. You are gonna follow this if your x is less than 4. And you are gonna follow this if your x is equal to 4. Okay? It's like different regions of a question. So you won't be asked to graph it, but I think graphing is something that will help you kind of put this all together. Basically, you have a graph here. Where is all the drama happening? At 4, right? Basically, right here at 4, we have this divide. And we're gonna be in this section, we're gonna be using B. And then in this section, we're gonna be using A. And then right here, only at 4, we're gonna be using C. Does that help kind of build it in your head? When you're bigger than 4, you're supposed to be using A, and when you're less than 4, you're supposed to be using B, and when you are exactly 4, you're supposed to be using C. Now, again, you don't have to graph this question. Now, we could answer many, many, many questions about this question. question here. Okay? What if I asked you, what is f of 4? Is this a predicted value or is this the true value? This is the true value. What is it actually at 4? It's 10. Where's that number 10 coming from? It's coming from the c function. The answer is 10. Everybody feel pretty good about that? Okay. What is the limit of f of x as x approaches 4 from the positive side? Basically, we're just having this little game in our head. Where is the 4 supposed to go? Are we supposed to be plugging 4 into A or B or C? For this question, coming from the positive side, which one is that?
A.
It should be A, right? We're looking to come at 4 from the positive side. So we're looking to do this, and so we need to use the function that has power over here. We're looking to use the A function. So what we're looking to do is use the A piece, 2x plus 3, and then put a 4 in there. So what is the limit as x goes to 4 from the positive side? 11. Okay, what is the limit as f of x approaches 4 from the negative side? Should be a pretty easy process now. We're not going to use A anymore. We're going to be using B. We need to come from the negative. We need to come from the left side. And what is the answer for this? What do we got? 11. Exactly. Okay. What if I wanted to know what is the limit as x, or I should say the limit of f of x, as x goes to 4 with no minus and with no plus? I heard 10, I heard Devin mumble 10, I'm not sure if he's locking that in. It's either 10 or it's 11, right? I mean, it's one or the other. Are we all agreeing 10? Anybody want to throw in a towel for 11? We got an 11. Any more 10s? What are you going, Grady? Infinity. Okay. This is an easy question. What this limit is what do we predict is happening? Remember, in order for this limit to be real, both of them have to agree. So importantly, this right-sided limit and this left-sided limit have to be the same in order to have a regular limit. Is the left side and the right side limit the same? Yes. The answer is 11. Now, 10 is a horrible guess. Only because 10 is what happens in the real world, and that does not matter when it comes to the limit. The limit world is its own separate thing, right? Limit world is all about predicting and expecting, and this true value doesn't really matter. Even though f of 4 is 10, the limit as x goes to 4 is that I think it's going to be 11. When it comes to these piecewise, you just got to have some guts, okay? These are quitter killers, okay? People who just kind of gave up at the end of the notes and they, don't even want to try them. Okay? I don't think they're really all that bad. Okay. Here's what I got. We were doing so good, that last page took us forever. Or it took me forever. I'm not trying to put blame on you guys. I think that's enough for this.